Okay, guys, we're going to continue talking about functions today. You can certainly make some notes in your notebook about this, but we're not doing a separate note page. We just want to talk a little bit more in depthly about function notation and what you can do with it. So in addition to using it, obviously, to write a function, we've learned that we can be given an input and we can find the output. But there can also be computation between functions. So functions can be added, subtracted, multiplied, or divided, right? Imagine if you think about that function machine, what if you have more than one machine in your shop? And depending on the machine, what you put into it produces a different outcome. And if you want to know everything that you've outputted, you would have to add all of your function machines together. So that's kind of the premise of today. So here are some examples of adding, subtracting, multiplying, and dividing. So first off, we're going to, given these functions, f of x equals 4x minus 5, g of x equals 2 minus 3x, and h of x equals x squared plus 1. The first one, you can see it asks us to add the output of f of 2 plus the output of g of 3. So what I'm going to do is I would take the same thing I would do here and evaluate it, and the same thing here and evaluate it. So it's like just doing two problems like we did yesterday and putting them together. So what is that going to look like? When I put it into the first function, you'll notice I use brackets to mark it. So I'm going to have 4 times 2 minus 5. And then for g of 3, I'm going to have the 2, the minus 3, and then I'm putting in 3. And I'm just doing the math here then. So 4 times 2 is 8, minus 5, 2, negative 3 times 3 is negative 9, or subtracting 9, leaving me with 3 plus negative 7, and my total then would be negative 4. So in other words, f of 2 plus g of 3 equals negative 4. So what if I have subtraction? You'll notice I've kind of written the same problem twice, and this is just two different ways you can see it. In this example, the inputs that are going into both machines are the same. So instead of writing it like this, you may see it written somewhat like this. Could have those brackets, could not have those brackets. Could just say h of x minus f of x and then have a parenthesis afterwards for 1. And this is just telling us that basically the same input is going into both functions. So what would this look like? So we start off, h is up here, x squared, so I have 1 squared plus 1, f4 times 1 minus 5. And again, I'm just doing the math. 1 squared is 1, bring down the other one. Bring down my subtraction sign. 4 times 1 is 4, and I still have my minus 5. I'm left with 1 minus negative 5. And we should remember when we double dash, right, when you're subtracting a negative, that actually is the same thing as adding. And if we add 1 and 5 together, we're going to get 6. So h of 1 minus f of 1 is equal to 6. Okay, C, this is an example where we're multiplying the functions. Now you could actually multiply the functions out without putting in their inputs and then put in the inputs if they were the same, but that's not the case here. So we have to do them separately. So we have g of negative 3 times h of negative 2. Go down a little bit further. So in the parentheses, let's see if I can make it. So we can see g of x was 2 minus 3x. So 2 minus 3, and the new x is negative 3. And h was x squared plus 1. So negative 2 squared plus 1. So these are what trips a lot of kids up, is this signage, right? We have to remember, we're not just subtracting here. This is a negative 3 times a negative 3. And when you're multiplying, two negatives make a positive. Over here, -2 is being squared. So when I square that, -2 times -2 is going to give me a +4. So I'm really left with all positive numbers now. So 2 plus 9 is 11, 4 plus 1 is 5, and when I multiply them together, I'm going to get 55. In other words, g of -3 times h of -2 is 55. Okay, and the last one, I know this is kind of hard to tell. It might look a little bit like a plus sign. I'll zoom in just a little bit more. Maybe that's a little too much in terms of being able to see each other really nicely. That is a division sign. Center it a little bit more. So I have g of 4 divided by f of 0. Okay. So g of 4, g is 2 minus 3x. So I have 2 minus 3 times 4 divided by f of x is 4x minus 5. So 4 times 0 minus 5. And again, I'm just doing the math. 2 minus 12, because 3 times 4 is 12, divided by anything times 0 is 0. So I'm just going to bring down that -5. This to the side now. So -10, 2 minus 12 is -10, divided by -5. When I divide, two negatives are going to make that positive. So g of 4 divided by f of 0 is going to equal 2. So you can really see how critical your integer rule skills are here, that we need to understand when we're adding something, same sign, add, opposite signs, subtract, and you always keep this. If you're adding same signs, you're going to keep the same sign. If you're subtracting, you're going to keep the sign of the larger one. When you're multiplying and dividing, it's about how many negatives or how many negatives you have. So if there's two negatives, they cancel each other out. So if you have an even number of negatives, like here, an even number of negatives, it's going to make a positive. Okay, even number of negatives, right? Because 2 is an even number, it's going to make it a positive. 1, 2 -3s, it's going to make it a positive. So odd number of negatives would make it a negative. So that's kind of like reviewing your integer rules, how critical they are here. So after this, you have 2 GP pages to do. Zoom back out so you can see them. So you have GP4, and I know this says GP4, but it will say GP5 by tomorrow. Those are the 2 GPs you have, and then you may have an activity in your classroom as well.